Explain what ASHRAE 110, what it means to laboratories. ASHRAE 110 is a document which advises tests required on an annual and 5-year basis to verify the safe operation of fume hoods in laboratories. This document was last modified in 1995 and offers test procedures to be used in laboratories throughout the USA, Canada, and other countries. Note: in federal government laboratories in Canada, the MD152128 guidelines are in effect. The MD152128 guidelines were produced using ASHRAE 110 test procedures. MD152128 guidelines will advise what will cause a fume hood to fail, whereas ASHRAE 110 simply explains the test procedures to be used. As noted in ASHRAE 110, the performance of a laboratory fume hood in providing protection for a technician at the face of the hood is greatly influenced by the design of the fume hood, the design ventilation of the lab, and the placement of other exhaust devices in the lab. There is a requirement to establish an as-used performance rating, which will differ from the as-installed and as-manufactured performance rating. This document does not suggest safe operation procedures for the lab, as only the lab manager can do that. It suggests safe operating performance of the fume hoods. However, fume hoods are considered by many to be the primary safety device in the lab. Other exhaust devices are canopies and exhaust arms. Below listed are important factors to be considered in the safe operation of the lab that are not dealt with in this document. Terms: cross drafts. Air currents may be, by creating turbulent air pockets, draw contaminants from the fume hood. These cross drafts could be caused by air supply diffusers or grills, open windows or doors, or the movement of people in front of the hood. Work procedures. There exists substantial evidence to suggest that all work in a fume hood should be conducted as far back in the hood as possible. Users have standardized the requirement that all work should be done a minimum of 6 inches behind the face of the sash opening, or further back if possible. Internal obstructions. The location of too much laboratory equipment in the fume hood will disturb airflow patterns in the hood. Procedure being used. The intrinsic hazard of the procedure being performed can affect the level of safety of the technician. Thermal consideration. Heat produced in the hood can cause significant disturbance in hood performance, and can even cause leakage of warm, contaminated air from the top of the hood or from the sash. Rate of response. The transient state or interval required for a variable air volume hood to respond to a rapid opening of the sash, or the time interval required for a hood to respond to a change in static pressure in the main exhaust duct serving multiple hoods. This may affect hood performance. Thank you very much for listening.